You don't write anything. Just watch and think. What's that shape?
Triangle.
How many degrees is inside a triangle?
360.
180 degrees. Right? Everybody good there? What if I made a quadrilateral?
200 trays.
How many triangles are inside a quadrilateral?
2.
2 triangles. And each of those triangles is 180 degrees, so total makes 360 degrees. Okay? 5-sided shape's called a what? Pentagon. How many triangles are inside a pentagon?
3.
1, 2, so 3. If each of those has 180 degrees, how many total degrees is inside of there? 540. 6-sided shape's called a hexagon. How many triangles inside a hexagon? So, has anybody discovered a pattern yet?
I have.
Is that 720?
I have one.
What's the pattern?
You can connect any two points that are already connected to make a triangle.
Right. So here we had how many triangles? 1. Here we had 2. Here we had 3. Here we had 4. Can someone, Dominic, stop, or you're going to the office. Today is not the day. Can anybody come up with a formula that could determine how many triangles are inside a shape? Nolan.
180 times x equals.
Just triangles. Don't worry about the 180 yet. How many triangles are inside each shape?
True.
Here we had 1. Here we had 2. Here we had 3. Here we had 4. What's the relationship between the number of sides the shape has and the number of triangles inside it?
Triangle and there is side.
You're minusing 2, right? Here we had 3 sides. How many triangles? 1. Here we had 4 sides. How many triangles? 2. Here we had 5 sides. We had 3. Here we had 6 sides, and we had 4. So if I had 7 sides, how many triangles would be inside? 5. If I had 8 sides, how many triangles? 6. So if we think about how many triangles are inside, Jamin, how many triangles are inside each shape, what do I do with the number of triangles then to get to the sum of the interior angles? Well, we already did that. That gets us the number of triangles. How do I get to this number then? You don't add 180. If I had 3 triangles, I would multiply it by 180 to get 540. If I have 4 triangles, I would take 4 and multiply it by 180, right? So if we take our number of sides and subtract 2, that gets us how many triangles are inside the shape. To get all the interior angles, I would then multiply it by 180 degrees, right? So that's our interior angles. Now let's think about exterior angles. Let's think about an equilateral triangle. All the angles are 60. Yes? Okay. Look at this exterior angle. What would be the degree of that exterior angle? How do I know that? What did I say? They are a linear pair, so that becomes 120 degrees. What about this exterior angle? That would be 120 degrees. What about this exterior angle? 120. So since there's 3 interior, there's got to be 3 exterior. What did the 3 exterior add up to, Jamin?
3 exterior, 2.
Yep, 120 times 3 is what? 120 times 3. 360. So there are exterior angles added up to 360. What if I change the triangle to to a 45, 45, 90. Those are easy numbers to work with. See if that stays consistent. What would be this exterior angle? 135. What would be this exterior angle? 135. And the other one would be 90. What's 135 plus 135?
It's 270.
270 plus 90. 360. All right, so there we just did two examples where it doesn't matter what the interior angles were, the exterior is always added up to 360. Okay, let's look at a rectangle. That one's easy to work with. Erase. What are the interior angles of a rectangle's degree?
90.
They're all 90. So what would be the four exterior angles? 90. If there's four 90s, what's 4 times 90? 360. That's interesting. What if I turned it into a parallelogram? So let's go like this. I'm going to make this 60, that one 20, that 60, and that one 20. What would be this exterior?
120.
120. What would be that exterior? 60. What would be the other two?
60 and 120.
120 and 60. Add those up, what do we get?
360.
We're going to get 360. All right, let's look at a pentagon. Pentagon has how many sides? 5. If all of them are the same, so let's make all of the angles the same. What did we say the sum of the interior angles of a pentagon was?
540.
540, right? Because we had 3 triangles. So 540 divided by 5 would be what?
108.
108. So if all of these are 108, what would be your exterior angles? 72, right? So your exterior angles would be 72. How many exterior angles would there be? 5. What's 72 times 5?
360.
360. That's interesting. What if it was a hexagon? What would be all your hexagons' interior angles if they were all the same? How many triangles? 1, 2, 4. 4 times 180 is what, 720? What's 720 divided by 6? They're all the same.
120.
Yep. So if all the interior 170 or 120, what's the exterior?
60.
60. How many exterior would there be?
6.
60 times 6 is
360.
360. Does anybody see a pattern? So doesn't matter the shape, the sum of the exterior angles end up being how many degrees? 360. There is most of your lesson for today. So let's put this into our notes. So before we can even talk about interior and exterior, we got to make sure we know the difference between the two. So the angles inside of your polygon are your interior angles, and the angles on the outside are your exterior angles. You should always have the same amount of interior as you do exterior. And what's the relationship between every interior and exterior angle? Dominic.
They add up to 180.
Perfect. They're linear pairs, so they add up to 180. So we've got some formulas we need to jot down. To find the sum of the interior angle of any convex, what does convex mean again?
All congruent angles.
Well,
The measure of the angles are the same.
not necessarily. That's regular. They're all the same. Convex means there's just no indents, right? No indents into the shape. So as long as it's convex, which all of them will be, you take your number of sides, which we're going to use the variable n to represent number of sides, minus 2 times 180.
Would the process change if it was not a convex?
Yeah, and then we wouldn't have a formula for it. So if it was like this, then it would have a different sum. All right. So first example, find the sum of the interior angles of a 14gon. So 14 gon means we're going to have 14 sides. So we're going to do 14 minus 2 times 180. 14 minus 2 is 12. 12 times 180, what do we get?
2040.
2060?
60? 21.
You have a calculator.
12 times 180, 2160. So 2,160 degrees. Dominic, question.
Isn't it true that every polygon after 12 sides is just called the number gon?
They have actual names, but you are not required to know what those names are. I don't even know what those names are. So if I don't know them, you don't need to know them. So just put the word gon afterwards.
Did you have to learn them in school?
No, I actually never did. That's a good question.
Only scientists have to. But no, not scientists.
All right, let's work backwards. Here they give us the sum. Can we figure out how many sides the shape had?
Ooh.
So let's set our formula up. So the sum of your angles is equal to n minus 2 times 180. I always solve that equation for n. Yeah, I would divide out the 180. I would not distribute that 180. You might be tempted to do that because of the parentheses. But I'll just give yourself more work. It's not incorrect. It just gives you more work. So 4,320 divided by 180 is what? 24. So 24 is equal to n minus 2. So what's my last step to get n by itself? Add 2. So 26 is equal to n. So we'll just call it a 26 gon for our shape. What, Dominic?
Now I'm looking at this. Eventually, wouldn't we be able to just like make a whole table that knows what each shape's interior angles equal to?
Yeah, probably could. All right. So now, what happens if I turn my shape into a regular polygon? Remember, regular polygon means all the angles, all the sides are congruent. So if all of the angles are the same, just like we were doing in that demonstration that we were doing, what do I do to the sum of the angles to get just an individual angle? So if the sum of the interior angles of a triangle is 180 degrees and it's a regular triangle, what's each individual angle? A regular triangle
60.
is going to be 60, right? How do we do that? 180 divided by 3. If I had a square, 360 degrees, or inside a quadrilateral, you would do 360 and divide it by 4 to get 90, right? So if you're asked to find an individual interior angle, all you're going to do is you're going to take that sum, which we just practiced finding, and divide by n. So take notice, this only works if you're told that your shape is regular. Because if it wasn't regular, then all your angles may not all be the same. And we can't just divide it and assume that they are going to be all the same.
Well, why do we have to divide it for this one? How does it change that?
Well, if it says find the individual interior angle of a regular decagon, that means all the interior angles are the same. Okay? All right, so let's do this example on the bottom. Oops, come back. What is the individual interior angle measure of a regular decagon? So decagon has how many sides? So, oops, I'm in highlighter mode. So n is equal to 10. So that means we're going to do 10 minus 2 times 180. And then take that number and divide by 10. So 10 minus 2 is 8. 8 times 180 is, 1,440. Divided by 10, just take away a 0. So that means if I had a regular decagon, meaning all the sides are the same, all the angles are the same, then each individual angle would be 144. If each individual angle is 144, what would be the exterior angle? You can find that very easily.
616.
36.
36, because it would be the supplement of 144, right? So we said that the interior and the exterior are supplementary of each other. All right, flip on to the back for exterior. Exterior, there is no trick to it. It's so easy that you guys are probably going to get it wrong on your quiz, because it is that easy. There is no formula. All your exterior angles will always add up to 360 degrees. Does not matter what the shape. If it asks for the sum of the exterior angles, your answer will be 360 degrees. So for our first example, find the sum of the exterior angles of a convex 20-gon. The answer is going to be 360 degrees. It's so easy. You're going to mess it up. I'm telling you now. Don't do it. Find the sum of the exterior angles of a convex 101-gon.
That would be like 0.36 for all of them.
Well, that's if we had to do individual. Right here we're doing just sum.
Or 3.6, I don't know.
So it would be 360 degrees. What's our formula going to be to find just an individual? So what was Dominic trying to do in his head right then and there? Well, we know that the sum is what? 360. To find an individual one, we're going to divide by
the amount of sides.
n. So 360 divided by n. So for this one, find the individual measure of an exterior angle of a regular dodecagon. How many sides is a dodecagon?
It's 11 or 12.
It is 12. So now we're going to take 360 and divide it by 12, and we get 30 degrees. Okay, so pay attention to what it is that's asking for. Is it asking just for a sum? Then you need to decide, is it exterior, which means it would be 360, or is it interior, which means it's going to be n minus 2 times 180, or is it asking for an individual angle? And if that's the case, then you need to find your sum and then divide it by the number of sides. Dominic, what's your question?
Don't I forgot.
All right, so now, in all of those problems, you are given the shape as a name. Now you're going to be given the shape as a diagram. How many sides does this shape have?
4.
4. So we know we've got 4 sides. Are my angles in the interior or the exterior? The interior. What formula do you use to find the sum of the interior angles of a polygon?
Add all this together and subtract.
Right. Now this one's easy because it's a quadrilateral, and most of us know quadrilaterals are going to add up to how many degrees inside? 360. But it might not always be a triangle or a quadrilateral, so you need to make sure you think about how to find what the sum is going to be. So I know that my sum of all 4 of those angles should add up to 180 or 360 degrees. Well, let's add up these numbers. What is 108 plus 121 plus 59?
292. No.
I think it's 288, isn't it? 108, 21, 59. 288. So x plus 288 equals 360. Subtracting that from 360 gets us 72. So x is equal to 72. What would change in this problem if this was a pentagon? Instead of 360, our number would be 540. If this was a hexagon, what would it be? 720. And those are ones you should come up with pretty easily. So I don't know if you want to make a quick sidebar and say that a triangle is 180 degrees, a quadrilateral is 360 degrees, a pentagon is 540, a hexagon, we said was what, 720? Okay. I mean, those should be basic ones that we should be able to just kind of pop up with our head pretty easily. If you don't remember those, there's not a problem. Just use your formula. What if this was a decagon? Then what would we do? 360 would turn into what?
3,000.
So 10 minus 2 is 8. 8 times 180. Didn't we do that on the front side? When we do decagon? What is 8 times 180?
2,150.
Yeah. So this would turn into 1,440. Okay? So pay attention, especially for the interior. How many sides do you have? That's what's going to determine what this equals to. Don't make it always 360 for interior, because it's not true. It is true for your exterior. Notice in the second example here on the bottom, these are all exterior angles. It does not matter how many exterior angles you have, because we said that the sum of all polygons' exterior angles add up to 360. So when you see those exterior angles, you should be thinking, awesome, I don't need to do that much thinking, because all I'm going to do is add them up. So 2x plus x plus 67 plus 89 equals 360, and solve that equation. So 2x plus x is 3x, 67 plus 89 is 156, equal that to 360, subtract 156 from both sides, equals, no, so that would be, oh yeah, 204, divide it by 3, so x is equal to, what am I doing? 3 goes into 20 how many times? 6, 18, 3 goes into 24, 68.
That's what I thought.
So x equals 68. Okay? All right. Grab yourself a quick practice space. I want to